In this video, we will rationalize the denominator, make it rational with no roots, using conjugates. The first thing we have to understand is what is a conjugate. I have three expressions here, all binomials, two terms, and the conjugates will be very simple to find. Basically, all you have to do is if it's a minus sign, you change it to a plus, and if it's a plus sign, you change it to a minus. So each conjugate, this conjugate here of 3 minus root 2 would be 3 plus root 2. The conjugate of 12 plus I is 12 minus I. And the conjugate of 6 minus 5 root 3 is 6 plus 5 root 3. That's all a conjugate is. Now, why is it important? Let's multiply this expression times its conjugate. So we will do 3 minus root 2 times its conjugate 3 plus root 2. Here's why it matters. What we have to do is technically FOIL this, right? So we'll distribute the 3 through, and then we'll distribute the minus root 2 through. So we'll get 9 plus 3 root 2, distributing the 3. Then we'll distribute this minus root 2 through, and when we multiply the minus root 2 times the 3, we'll get minus 3 root 2. And then when we multiply negative root 2 times positive root 2, we'll get minus root 4. And what is root 4? It's 2. So root 2 times root 2 is plain old 2, and it's a negative times a positive, so it'll be minus 2. All right, now we have a plus 3 root 2 and a minus 3 root 2 over here. Those cancel out, so we have 9, and then those middle two terms cancel, minus 2. We end up with a really nice value, one number. Now, the most important thing about that is that we started with two expressions that were irrational. We started with this first expression that was irrational. Multiplying an irrational binomial like this by its conjugate will lead us to a rational number. So that's why it's important. Let's take a look at an example using a conjugate. All right, so in this example, what we want to do is rationalize the denominator using the conjugate of the denominator. So we are going to multiply both the numerator and denominator by the same thing, and that is the conjugate of the denominator. So we're going to multiply by 6 minus 2 root 3 in the numerator and the denominator. So in our numerator, we'll multiply the 5 through, and we'll get 30 minus 10 root 3. In our denominator, we saw before that those middle terms are going to end up canceling, the ones with the roots in them. So instead of multiplying and getting 4 terms, right, instead of distributing the 6 to both and the 2 root 3 to both, we don't need to do that. All we need to do is multiply the 6 times the 6 and the 2 root 3 times the minus 2 root 3. Because those inside two terms, if you think of it as FOIL, the O and the I, will cancel. So we only need to multiply the first and the last, and that's the beauty of conjugates. So we're going to multiply the 6 times the 6. And again, this only works because they're conjugates. And we're going to multiply the 2 root 3 times the minus 2 root 3. Now I know we're going to get a minus, and 2 times 2 gives us 4. But we're not done. The root 3 times the root 3 gives us a 3, a plain old 3. So this is really a 4 times a 3 here. So what we have in the numerator is 30 minus 10 root 3 all over 36 minus 12. So we have in the numerator, we can factor out a 10, it looks like, if we need to. So we'll factor out the 10, so we'll be left with 3 minus root 3. And then in the denominator, we have 24. We can cancel the 10 and the 24 by dividing them both by 2. So we'll have a 5 and a 12. And our final answer is 5 times the quantity 3 minus root 3 all over 12.